Welcome to History with Herodotus, where we embark on a journey through the ages, uncovering the secrets of our collective past. Today, we find ourselves at the threshold of a most pivotal era, the scientific revolution. This transformative period, which spanned the 16th to the 18th centuries, witnessed a seismic shift in human understanding, as the tried and tested certainties of ancient wisdom gave way to the bold and innovative spirit of scientific inquiry. In the midst of the Middle Ages, the dominant intellectual landscape was shaped by the Aristotelian worldview, which had been painstakingly preserved and interpreted by the great minds of the Islamic Golden Age and the scholastic thinkers of Europe. The likes of Avicenna, Averroes, and Thomas Aquinas had woven a complex tapestry of knowledge, seeking to reconcile faith and reason as they navigated the intricate pathways of philosophy, theology, and natural history. During this period, the works of ancient Greek philosophers such as Aristotle and Plato were meticulously studied and translated, their ideas influencing the development of various fields from medicine and astronomy to mathematics and physics. The recovery of classical knowledge, facilitated by the tireless efforts of scholars like Gerard of Cremona and Adelard of Bath, sparked a renewed interest in the natural world as thinkers began to question the established order and seek answers through observation, experimentation, and reasoning. As we move forward in time, we find ourselves in the midst of the Renaissance, an era marked by an explosion of artistic, literary, and scientific creativity. The likes of Leonardo da Vinci, Michelangelo, and Galileo Galilei were not only masters of their respective crafts, but also polymaths whose insatiable curiosity and innovative spirit would lay the foundations for the scientific breakthroughs that were to come. The Renaissance humanists, with their emphasis on individualism, intellectual curiosity, and classical learning, created an environment in which the seeds of the scientific revolution could take root. In this fertile soil, we find figures like Copernicus, who, in his groundbreaking work, De Revolutionibus Orbium Coelestium, would challenge the geocentric model of the universe, proposing instead a heliocentric system that would send shockwaves throughout the intellectual community. The likes of Andreas Vesalius, with his meticulous anatomical studies, and William Harvey, with his pioneering work on blood circulation, were also pushing the boundaries of human knowledge, their discoveries illuminating the intricate workings of the natural world. As the 16th century drew to a close, the intellectual landscape was ripe for revolution. In 1609, Galileo Galilei, armed with his improved telescope, gazed up at the night sky and observed 4 moons orbiting Jupiter, providing conclusive evidence for the Copernican heliocentric model. This discovery sent shockwaves throughout the scientific community, as it challenged the long-held geocentric view of the universe. The publication of Galileo's Sidereus Nuncius in 1610 marked a pivotal moment in the scientific revolution, as it not only presented irrefutable evidence for the heliocentric model, but also showcased the power of empirical observation and experimentation. The following year, Johannes Kepler published his seminal work, Astronomia Nova, in which he presented his laws of planetary motion. These laws, based on meticulous observations of the planet's orbits, further solidified the heliocentric model and laid the foundation for Sir Isaac Newton's groundbreaking work on universal gravitation. As Kepler himself noted, "I am merely a gatherer of pebbles on the beach of the vast ocean of knowledge," highlighting the collaborative spirit that defined the scientific revolution. In 1616, the Catholic Church, still reeling from the implications of Galileo's discoveries, condemned the Copernican heliocentric model as foolish and absurd. Undeterred by this setback, scientists like Francis Bacon and René Descartes continued to push the boundaries of human knowledge. In his Novum Organum, published in 1620, Bacon advocated for a new approach to scientific inquiry, one that emphasized experimentation, observation, and the systematic collection of data. This empiricist philosophy would come to define the scientific revolution, as scientists increasingly turned to the natural world for answers rather than relying on ancient authority. As the 17th century progressed, the pace of discovery accelerated. In 1628, William Harvey published his treatise De Motu Cordis, in which he presented his revolutionary theory of blood circulation. This work not only transformed our understanding of human anatomy, but also demonstrated the power of empirical observation and experimentation in advancing scientific knowledge. The following year, Pierre Gassendi, a French philosopher and scientist, conducted a series of experiments that led him to formulate the concept of the corpuscular theory of matter, which posited that all material substances are composed of tiny particles. The 1640s saw the emergence of the Royal Society in England, an institution dedicated to the advancement of scientific knowledge through experimentation and collaboration. Figures like Robert Boyle, Robert Hooke, and Isaac Newton would come to dominate the Society's proceedings, presenting papers on topics ranging from the behavior of gases to the nature of light and color. In 1665, Newton, then a young scholar at Cambridge, began developing his theories of calculus and universal gravitation, which would eventually be presented in his masterpiece, Philosophia Naturalis Principia Mathematica. The year 1668 saw the publication of Francesco Redi's experiments on the generation of insects, a work that challenged the prevailing theory of spontaneous generation and demonstrated the importance of empirical observation in understanding the natural world. As Redi himself noted, the senses are the windows of the soul, highlighting the centrality of observation to scientific inquiry. The following decade saw significant advances in the field of microscopy, as scientists like Antony van Leeuwenhoek discovered a vast array of microorganisms that had previously been invisible to the human eye. As the 17th century drew to a close, the scientific revolution had reached its crescendo, with scientists like Isaac Newton and Gottfried Wilhelm Leibniz dominating the intellectual landscape. In 1687, Newton published his magnum opus, Philosophia Naturalis Principia Mathematica, which presented his laws of motion and universal gravitation, providing a unified framework for understanding the natural world. This work had a profound impact on the development of modern science, as it not only explained the behavior of celestial bodies, but also provided a powerful tool for understanding the workings of the universe. The early 18th century saw the rise of prominent scientists like Alessandro Volta and Benjamin Franklin, who made significant contributions to our understanding of electricity. In 1747, Franklin conducted his famous experiment with a kite in a thunderstorm, demonstrating the connection between lightning and electricity. This discovery paved the way for further research into the properties of electricity and its potential applications. As the scientific revolution drew to a close, its legacy became increasingly evident. The emphasis on empirical observation, experimentation, and the systematic collection of data had transformed the scientific landscape, paving the way for major breakthroughs in fields like physics, chemistry, and biology. As the French philosopher and historian Condorcet noted, "The progress of science is unlimited, and its boundary is receded as it advances." This sentiment captures the essence of the scientific revolution, which had unleashed a wave of intellectual curiosity and innovation that would continue to shape human understanding for centuries to come. Today, the scientific revolution is remembered as a pivotal moment in human history, marking the transition from a geocentric to a heliocentric worldview and laying the foundations for the scientific and technological advancements of the modern era. Its impact can be seen in the countless discoveries and innovations that have transformed our world, from the development of vaccines and antibiotics to the creation of computers and the internet. The scientific revolution's emphasis on empirical observation and experimentation has also had a profound influence on the development of modern scientific methodology, with its focus on testability, falsifiability, and peer review. In conclusion, the scientific revolution was a transformative era that marked a fundamental shift in human understanding, from a reliance on ancient authority to an emphasis on empirical observation and experimentation. Its legacy can be seen in the countless scientific and technological advancements that have shaped our world, and its influence continues to be felt today. That's all for today's History with Herodotus. Remember to like, share, and subscribe, and until next time, remember that, to understand the present, we must first understand the past.